Yo, 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 CyberDucky is back. And today I want to talk about the debugger. What it is, how does it work, why do we even need it? Debugger is actually a program that you use when you have bugs. So you use it to find out why you have a bug. You triage a bug. And it's actually super useful for you to know this. You need to know how to find a bug, what part of your code is slow, what part of it's going fast, what is causing this issue, and then you need to solve it. So in this video, we're going to go through code execution flow, breakpoints, and how to look at some variables in memory. We're going to debug a authentication program that we quickly wrote up, and we're going to try to find a secret that is running in memory. It's hard-coded in the program, and we're going to try to pull it out. Pull out that secret. So let's go. So going right into it, we have our main program here. We're using put string to print out all of these different kinds of authentication terminal looking text, right? So we're gonna prompt the user down here in fgetString, and we're gonna ask them to give us the authorization code. What is the authorization code and when will we let you in? Okay. One cool thing to note here is that put string will always add a new line character at the end of every string versus printf, which is used to format strings as you want to. So just something cool I learned. So before we continue, I want to point something else out. There's this char here, this input character array of 128 bytes. Looking at this, you know this could be an issue if whatever the user inserts is over 128 bytes, right? It could cause a buffer overflow. We need to prevent that. So here, we're essentially going to use fgets to prevent that. We'll have the input that the user inputs, and then we're going to max it at the size of that input, which is 128 bytes, and we're going to get that input from standard input. If it goes above that and somebody is trying to cause a buffer overflow, we'll just close the program and call it a day. You're not going to be able to buffer overflow us. So once we get the input of this user, we'll go ahead and we'll check the password. If they get the password correct, we'll print out, hey, you're verified, and we can continue. You're allowed to do X, Y, Z. If not, invalid. We're going to log your IP and we're going to blacklist you. And then after it's done, that's it. That's the whole program. It just checks the code and it prints out yes or no. Now let's go see this check password input. So this is pretty cool. Up here, you can already see that the secret is up here outside of the function, which means it's global. So it's not local to the function, it's global, it's above. Any of these functions can use it. We add the input that was given from the user. And here we create another character array of 64 bytes. And we're going to copy the input from the user to this buffer. And we're going to max it at the size of buffer -1. So 63. Because we need to make room for the null terminator, string terminator, which is this here. This is a string terminator. We need this in order for the program, for C to know that this is the end of the string. So I actually added up here as well. But if we're also going to check if there is a new line character at the end. If there is, we'll replace it with a null terminator. Now we continue. Now here is a pretty cool function. It's called string compare. All it's going to do is compare the buffer, which was what was given to us, the input. It was just copied over to this buffer with the global secret. If that is true, it'll return 0 and it'll say access granted. If it's not true, intrusion detected, error, red alerts, everything's bad, and then we move on. When this program is running, we want to see what secret is. In this case, if you're just a user and you're trying to type something in, you're going to have to keep guessing, right? Keep guessing the right password billions, hundreds of billions of times But if you can find what's inside the password, if we can find what's inside the secret, copy paste, we're in. Now that we've gone through the code, let's compile it, let's run it, let's see what the program looks like, let's play around with it, and then we'll start GDB, or GNU Debugger, which will be the debugger we're using for this. We'll set some breakpoints, and we'll start looking at what it really looks like inside memory and pull that secret out. So here, I already have my makefile up and ready. And I'll make another video on how to read a makefile and how to make a makefile from start to end. But for now, we're just gonna make run. Okay, here is the actual program. Classified access terminal. Unauthorized access prohibited. All attempts are monitored. Which, if you think about it, if you're logging in like SSH or you're trying to log into some port somewhere, you'll probably get something like this. So this is something we made. Now enter auth code. Let's try malware. Invalid auth code, intrusion attempt detected and logged, IP address recorded, connection terminated. So let's try again. This time let's just type in a bunch of characters. Malware, whatever, you know. Let's just keep going. 128 bytes worth. I think that's about it right there. Let's try. Enter. Didn't do anything so far. Let's try one more time. Let's see what this does. Okay, we see. It's simply just exiting still. Huh. Okay. We can come back to that. There must be some bug in there. See what I did there? All right, well, we see what the program looks like. We see that it just exits, and that's not good for us. So what we want to do now is run the debugger, and let's see the inside of this program. So if you already have GDB installed, you can just do GDB, and then the exe file, which is spy.exe, and enter. Now it's running. We're running the program and we stopped it. We can set something called breakpoints now. Breakpoints are like essentially pause points. You can put a point where to pause. And this will tell the debugger, hey, pause right here. Let's look at the variables. Let's look at the memory here. Let's look at what's going on. And then I can say continue, or put another breakpoint, or inspect the variables, or let's check this memory. So we know already that there is a main function. Most programs will have main. So you can say break at main. Okay. And then in order to actually run the program from here, just do run. So we stopped at line 44 at this printf. So we go here. Right here is where it stopped. At the first actual action. It's printing here. Now, one thing we can do, we can either step over, we can continue by typing next. So it'll go to line 45. And you can keep doing next line, right? This can become a bit tedious. I don't want to do all this. What I want to do is just type in continue to just keep running. Now it ran all the way to this line here, right where we're getting the input. Now I'm going to enter anything here, malware, and it exited, okay? Now this breakpoint that we set up earlier is still there. Now we know there's another function called check password. Let's write another break, check password. Perfect. Now, let's run it from the beginning. Okay, we're going to continue. And then we are going to tell it whatever here, whatever, bro. And then it hits the breakpoint on the check password function. If you look here, it's on line 26. The first actual action function. This is just an instantiation. This is an actual execution. Now, what we actually want is to go all the way down here to where the secret is being used, right? Because technically, if I'm just a user, I don't know that this secret up here is in the program. So I would have to just keep clicking next, next, next. Okay, I can see what the program is doing. Oh, here, string compare, secret. Now, if you want to check what is in the secret, you can do print secret. This will print the variable component, what's inside of it. CyberDucky subscribe is the actual secret. Now, there's something else you can do. You could do info locals, and it'll tell you other local variables that are in here. So it'll tell you the buffer, which is what we typed in earlier. Whatever, bro. And you can also do XS secret to see where this is at. So now we know the variable component, what's inside of it, and the memory address of that secret. Now later we can talk about pointers and how we can actually manipulate some of these and move whatever we want into this secret and just make a, let it bypass anything. So now let's actually copy paste this. Let's run the program again and continue here. Let's type in the code and just continue. There we go. Credentials verified. Welcome. Classified files unlocked. Deep web connection established. So in that, we learned a lot, right? We learned about GDB, the debugger. We learned about breakpoints. We learned about stepping through the code. And then we also learned about variables and being able to look at variables in memory. So essentially that's how you use the debugger. You can have a program that you compile, you execute, and then you can run the debugger on it. It'll help you debug, find bugs. It'll help you go through the code to see if there's performance issues or if you need to fix some certain things. You can also check the variables before and after certain steps to see if the actual contents are correct. Maybe there's duplicates of something in there that you don't want. Maybe it's not in the right format, so you have to go back and actually see it. It's hard when you're just going through the code and you can't see what's inside, right? So the debugger actually helps with all that. So I hope you like that. I'll keep making some more videos. I'm out here trying to learn C and try to teach everyone. So subscribe, comment, you know what to do. I'll catch y'all next time.